Hello and welcome back to the channel, Chatterjee Tutoring. In this video, we're going to go over Leetcode problem number 1143, which is a medium problem, longest common subsequence. Okay, the title is pretty descriptive of the problem, but just to make sure, let's go over the problem statement. It says, given two strings, text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. So the important part of this problem is what is defined as a subsequence. So it says a subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. We can show this because if we cut out the B and the D, we are left with ACE, and we have not changed the relative ordering of the characters. So the common subsequence is the subsequence that is common to both strings, and we have to find the longest common subsequence in the problem. Okay, let's look at the example. So in the first example, we see that ABCDE and ACE are the two strings. So we know from the problem statement that ACE is a subsequence of ABCDE. So in this case, ACE would be the longest common subsequence because it is found in both strings. For example 2, since the strings are the same, the longest common subsequence is the string itself. And then for example 3, there are no common subsequences because all letters are unique, so the result is 0. So how do we approach this problem? Well, let's look at it in simpler terms. Let's say we have two strings, A and A. So what is the longest common subsequence between these two? Well, it's just A. So the answer is just 1. So this is pretty obvious. We have A and B instead. So again, the answer is pretty obvious since they're both different characters. The answer is just 0. Okay, so let's build off of this. Let's say we add on a B to the first string. So now still we see that the longest common subsequence, the length is 1 because it's just A and A. So now if we add a C onto the other string, it's still 1 because B and C are different and the longest common subsequences are just A and A. But now what happens if we add on a C to the first one? Now we see that if we cut out the B from the first string, then AC and AC are the same. So now the longest common subsequence becomes of length 2 instead of 1. So why did this happen? It happened because the C that we added on was the same as the last character C that we added in the other string. So we see that if the last two characters are the same, we can cover them up, and then the new longest subsequence is just the longest common subsequence that was previously there, plus the new character that is the same. But if the last characters are different, that means that the longest common subsequence just stays, and we cannot update it. So we start to see a pattern here. So what does it sound like? We start with the base case and keep moving up, adding on more and more each time. That sounds like a bottom-up dynamic programming problem. So let's see how we can apply that to this problem. So how do we apply dynamic programming to this problem? Let's take again this example of ABCDE and ACE. So let's try to do exactly that, go from the bottom up. So first of all, we just take the first character here and the first character here, A plus A, and we just get 1 because the longest common subsequence is just A and A because we do not have to cut out any characters for them to be the same, and the answer is just the length of the string, which is 1. So now let's add on to the first one. So AB plus A. So we still get 1. And similarly, ABC plus A, we get 1, and all the way down to A, B, C, D, E plus A. The answer is still 1. Now let's take the second letter, so AC in the text 2, and then compare it with each substring in text 1. So we see that if we take A and AC, the longest common subsequence is still 1. And similarly for AB and AC, it's still 1 because only the A and A are common. But now when we get to ABC and AC, this is what I was saying before, we can take out the B and we're left with AC and AC. So this is actually 2. So the bottom up DP part of this problem comes because once we added on C, we saw that the letter C is common with the last letter C in the other text. So this is why if we hide the C over here and C over here, we just take A, B, and A. So this we had already calculated before in the previous list. So the answer to that one was 1. So since that one was 1, we know that C and C are the same. So 1 plus the extra character of C, so 1 plus 1 is 2. So similarly, we go on. So the last letter D is not same. So this is still 2. And similarly, A, B, C, D, E, and AC, it's still 2. So now let's look at the last and final character in text 2, which is E. So we're comparing each substring in text 1 with ACE. So initially we see A plus ACE. So this comes from A plus AC, which comes from A plus A. So A plus A we already know is 1. So therefore when we add on the B, so B is not the same as A. So we see that it's still 1. And then similarly ACE plus A is still 1. Now, similarly, AB plus ACE comes from AB plus AC. So that one was 1. E is not same as B, so this one is still 1. So now ABC plus ACE. So now we knew that AC plus ABC is 2, which we figured out in the previous section. So now, since we just added the E, which is not common in the last letter in the first text, this is still 2. Now ABCD plus ACE, so this is still 2 because we just added the D, so there's nothing changed. This is 2. And now finally we add on this E. So since this E and this E are the same, so as we said before, we just take the ABCD plus the AC, so that one was 2. Now we take that 2 and then add one more for the E, so our final answer is 3. And if you notice, ABCDE plus ACE, this is what we're trying to find. So in fact, this result that we find in the end is just our final answer, which is 3. So we can see that that is correct with the example problem. So how do we formalize this? Well, we saw that we were taking each substring from text 1 and comparing it with each substring in text 2. So we can actually represent this as a 2D array. Let's say that each cell in this grid represents the longest common subsequence that we have calculated so far for the substrings ending in that letter. For example, here we see A and A. So here the calculation is A plus A. So since A and A are the same, we have 1. So now we just move in a snake pattern. So we go all the way down this row. So AB, so B is not the same, so we get 1 again. And similarly, we go down this entire row and we get 1. So now let's move on. So AC plus A. So this answer is still 1 because we take it from the previous answer that we have before. So we actually bring this one down. Next, we go to AB plus AC. So now, again, we bring this one down. Actually, we can take the maximum of these two. So we take the maximum of AC plus A and A plus AB. So since they're both 1, we can just say that this one is also 1. So similarly, this goes down. So now we hit the point where we have C and C. So they're the same. So what we do, we discuss that we hide these two. So we hide the two C's. So we take A plus AB. So this is actually the diagonal. So we take the diagonal, move it down, and then we plus 1. So in this grid, the answer is 2. And then now we move on. D and C are not the same. So we take the maximum of these two, so which is this one, so the 2 moves over. Similarly, this one is 2. Now, finally, we come to the E. So E is not same as A, so this one moves down, we get 1. So E is not same as B, so again, these two come across, and we take the maximum of 1 and 1, that's still 1. So C and D are not the same, but this time we take the maximum of 1 and 2, and we get 2. So we can see this because ACE and ABC, if we cut out the E and we cut out the B, then we get AC and AC. So the answer is actually 2. Now we take ACE, ABCD, we bring these two across, we get 2. And now, finally, we get E plus E. So what happens here, we take the diagonal and then plus 1 to it. So 2 plus 1 is 3. And this is our final answer. Okay, now that we have formalized it, we can see the code for this problem. So initially, we take M and N to be the sizes of A and B, which are supposed to be text 1 and text 2. So we have M and N. So now we have a 2D vector, which is basically a 2D array, which is the grid that we had before, of size M plus 1 and N plus 1, which corresponds to each letter in each string plus 1. So that plus 1 will actually be filled with zeros. So now we go for I is 0 less than M. So this is for each character I in the string A. And similarly for each character J in the string B. So that's what N. So if they're the same, then we see that we take the diagonal, which is dpij, and then we add 1. So this is the new dp. And or else the new dp is the maximum of the two dp's before it. The one on the left, which is this one, the one above, which is this one. And at the end, we return the dp at the bottom right corner, which is just dp at M and N. So this works for every single test case. We can see it, submit, and accepted over here, success. So that's it for this problem. If you have any questions or feedback on the video, please leave it down in the comment section below. And if you like the video, please hit the like button and subscribe to the channel. Thanks for watching, and I hope you have a great day.